Behold Saturn. Its rings like a frozen river of light circling a pale golden world. Up close, the rings are a swarm of ice and dust, from powder grains to house-sized chunks. Spectra show mostly water ice with a dusting of darker material, why they shine so brilliantly in sunlight. The main rings are C, B, and A, separated by the Cassini division, a broad gap sculpted by gravity. Resonances with Saturn's moon Mimas tug here, clearing lanes and carving ripples that march like waves. In narrower gaps, moonlets lift scalloped waves. Daphnis stirs the Keeler gap with a moon-sized wake. Pan herds icy grains in the Encke gap, keeping edges sharp like a snowplow on a cosmic highway. The thin F ring is a troublemaker, braided, kinked, and bumped by shepherds Prometheus and Pandora. Though wide enough to span a planet, the rings are extremely thin, generally tens of meters, paper-thin on a planetary scale. From Earth, their tilt changes. Edge-on, they nearly vanish, then flare bright as sunlight strikes broader faces. Look near the sun's direction, and they surge in brightness. Tiny shadows disappear, and ice backscatters light our way. NASA's Cassini orbiter transformed our view, threading ring gaps and measuring their mass, texture, and motion. Grains constantly collide, chip, and reclump. Gentle traffic laws of gravity and ice set the lanes. Hidden moonlets carve propellers, small twin-winged gaps that cruise the ring like slow-moving fingerprints. Dark spokes sometimes streak the rings, charged dust lifted briefly by Saturn's magnetic fields. Micrometeoroids pepper the ice, kicking up dust that slowly darkens ring particles over time. Some ring material drifts inward as ring rain, falling along field lines into Saturn's atmosphere. Measurements hint the rings may be relatively young, tens to hundreds of millions of years, though scientists still debate their age. They might be debris from a shattered icy moon or a captured comet torn apart by tides. Waves ripple where moons tug in rhythm, each crest is a frozen record of an orbital beat. Saturn's magnetic environment sparks auroras and influences dusty spokes that form and fade with seasons. As seasons turn, sunlight angle changes shadows, temperatures, and the chemistry frosting grain surfaces. Particles wear mantles of frost and dust. Surface roughness and porosity control how they scatter light. Infrared views reveal temperature patterns, confirming different densities and grain sizes in neighboring lanes. In dense zones, self-gravity pulls grains into elongated wakes, mini streaks aligned with the traffic flow. The main rings span over 270,000 kilometers, wider than the gap from Earth to the Moon, yet remain razor-thin. The tiny moon Mimas, by resonance alone, sculpts the Cassini division without ever touching a grain. Along the F-ring, one nudge spawns clumps, the next pass smears them back into filaments. Pan's odd ridge may be ring snow stuck to an older core, proof rings and moon's trade material. Innermost, the D-ring is ghostly thin, a fragile veil close to Saturn's cloud tops. Farther out, the diffuse E-ring comes from Enceladus's geysers, snowing fresh ice into space. Rings, moons, and magnetism form one machine. Push here, pull there, and patterns shift across the whole system. In its finale, Cassini dove between Saturn and the rings, weighing ring mass and sniffing in falling molecules. On Earth, ring physics is tested in drop towers and space labs, slow, sticky collisions that mimic frigid ice. With a small telescope you can see the rings yourself, a perfect first target on a steady night. Watch through a year and the tilt changes. The show evolves even for backyard observers. A turntable and beads recreate the basics: spin, collisions, and a moon that clears a lane. Future probes may sound inside dense regions, mapping clumps and reading buried structure. The beauty here is really physics you can see. Gravity, light, and ice drawing patterns in real time. The longer you look, the more the system feels alive, shaped by steady rhythms and sudden flickers. Shepherds sculpt, spokes lift, waves march, and snow falls from geysers far away. Even in shadow, faint starlight threads the gaps, turning the rings into a lacework of darkness and shine. Saturn's rings are a masterpiece of simplicity and motion, ice, dust, and gravity making art. They won't last forever, but for now, they are the solar system's grandest performance. Keep looking and you'll start to read the physics and the beauty. Like, comment, and subscribe for more videos like this.